Welcome, this is Python and Excel part 25, and I'm looking at this out-of-the-box challenge number 97 from this gentleman here. Please go to his LinkedIn page, follow him. There's challenges every day to help you stretch your skills. I'm going to show you two ways of doing this in Python, but let me just explain the problem first. I've got a grid of letters, and for each column there is a number 1 through 6, and each row there is a number 1 through 5. We take a word and break it into its component letters, E, X, C, E, L. And for each letter, we find its column coordinate and its row coordinate, and we sum them. So this E is in column 5, row 1, column 5, row 1, and we sum it to get 6. We do that for all the letters, and we get these numbers. The result is then the concatenation of these numbers. 6, 10, 4, 6, 8 gives us this number here. The idea is to build a formula or a script or something that will do this for any kind of word. And I'm going to show you two ways to do that in Python. So let's get into that. All right, so let's take a look at the first solution. I've got it in cell A1. You can see it here. It's actually a single line. It looks a bit complicated though, so I've broken it out into different steps just to explain what's going on. And what we're going to do is we're just going to look through each of the steps and uncomment the lines so that we can see what happens. First of all, I have named the range, this range, I've named it letters, and the word cell is named word, just for simplicity in the script. So in the first example, I'm using the XL method to connect to the letters named range, and that returns a data frame, and the data frame looks like that. Now, I could continue working with the data frame, but actually this kind of task can be much faster and easier if we use NumPy arrays. So in the second step, I am now converting it into a NumPy array using the toNumPy method. We know it's a method because it has the parentheses after it. So that gives us something that looks the same, but it's actually a different type of object. It is now a NumPy array. On step 3, I am now using this np, which is NumPy.isIn method to ask if the letter E is in the NumPy array produced by the previous step. So is the letter E in there? And what it gives us is a Boolean array with false if the element of the array is not equal to the letter E, and true if it is. So it gives us a true here, which of course is equivalent to where the E is in the original array. So that gives us a Boolean array, and that is np.isIn. The next step is to use np.nonzero. And what that does is it looks for any non-zero elements in its first argument. And the first argument is the array above, and non-zero is going to be the true cells. And it returns the coordinates or the indices of the non-zero elements. So what it should do is return the index, the row index, which will be 0, and the column index, which will be 4, for this true in this array. The indices are 0 indexed. So it has returned the row index and the column index, 0 and 4. So that's great, but though the indexes on the original problem are actually 1 through 6 and 1 through 5, not 0 through 5 and 0 through 4. So to deal with that, we can, first of all, sum the result of those indices. So that will give us 0 plus 4. And then add 2, 1 for each dimension. And that will give us a result that is for the E in that problem, which is 6. And that is what we expected from the explanation of the problem statement. So on step 6, now we use a list comprehension. So instead of just doing a single letter, instead of just doing the letter E, we want to do each of the letters from the word in turn. And to do that, we can use a list comprehension. And we know it's a list comprehension because it is wrapped in these square brackets. And it's got this language here which says for C, C is just a variable. It can be anything you want, but I've used C for character. For each C in word, so that's for each character in whatever is in that word cell, perform the calculation that we did above. So that is do all of those different steps. And executing that gives us the numbers that represent each of the letters in the word. So E, X, C, E, L. In order to concatenate those, we need to convert them into strings. So Python isn't quite as forgiving as Excel in that respect. We do need to do something with it in order to concatenate them. So first we need to modify the list comprehension and wrap the calculation in this str method, which converts something into a string. So this will return a similar array, but it will be strings instead of numbers. And then finally, the last step is to use, oh, I've lost something here. Nope. Finally, the last step is to use empty string dot join, and then it will join whatever is in this list using whatever is before the join word as a separator. So if the separator is an empty string, then it will be joined, they will just be concatenated, basically. Now what I've done here is I've broken out the calls to the letters array and to the word, and I've taken them out of the list comprehension, which is more efficient because it will then only pull the data from the spreadsheet once instead of at each iteration of the word. So this is now 3 lines, but it's not a bad thing to have 3 lines instead of 1 if it makes the code more efficient. So 3 lines will then produce the result 610468, and that is the result of the first solution. Let's take a look at the second one. All right, let's take a look at solution number 2. This is solution 2. It looks a bit complex, but let's break it apart and see what happens. First thing to note is that if we wrap a scalar, which is produced by this Excel word, because that's a single cell, if we wrap a single cell, a string, in the list method, it creates a list of the characters in the string. We still want to work with an array though, so we're going to wrap that in np.array. We don't use toNumPy with this particular solution because toNumPy is a pandas method and we are not using pandas in this solution. So that is now a 1-dimensional array of the letters in the word. The next thing we're going to do is convert that 1-dimensional array into a 3-dimensional array, and the reason will become clear in a moment. But the way we do that is we use this slice, and in the first position for the first dimension, we simply return all of the letters from the 1-dimensional array produced previously. And then we create dummy arrays using the word none. We can also, I think there's also a keyword that you can use or a method that you can use there in place, but none is good enough. I'm going to print it to the diagnostics pane so that we can see what that looks like. This is the 3-dimensional array of the Excel letters. So it's got 3 opening brackets and 3 closing brackets. So that's a good sign that this is a 3D array. There is 1 letter in each layer along the z-axis. The next 2 steps are exactly the same as they were in the previous solution. So first of all, get the pandas data frame of the letters array and then convert it into a NumPy array using toNumPy. Just to demonstrate what happens if you compare that NumPy letters array with a single letter, it actually produces a Boolean array the same way that we used np.isIn in the previous solution. So here's the Boolean array with the true in the position of the e. It turns out that we can actually, in place of that e, we can compare the letters array with the word array, the 3-dimensional word array, and create a Boolean cube where each layer is a Boolean array representing the position of the letter in the letters array. So I'm printing it to the diagnostics pane so it's easier to see what's going on. Okay, here is the 3D Boolean array. There are 1, 2, 3, 4, 5 layers in this array, and each layer has 2 dimensions, and this represents the E, this represents the X, this represents the C, this represents the second E, and this represents the L. So that's the 3D Boolean array, and we're going to use that in the same way that we used it in the previous solution by calling np.nonzero to return the indices or the locations of the trues in that 3D array. So you can see here I'm using np.nonzero in the same way that we did in solution 1. What that gives us is this. So it shows us the layer that it appears on, the row dimension, the index on the row dimension, and the index on the column dimension. The next thing to do is to extract these into separate variables, and that is done with this second line here. I've separated 3 variable names and set it equal to the result of that statement, and that will essentially put the layer array into the chars variable, the rows into the rows, and the columns into the columns. And then I'm using f strings and list concatenation to just print a little message to the spreadsheet that shows us what the row and column indices are. So it says the row indices are 03001, which is this one, and the column indices are 45245, which is this one. Of course, the problem statement, the coordinates of the letters are 1 indexed, not 0 indexed. So we just need to add 1 to each of the elements of these 2 arrays. And that's actually really simple. You just add 1 in the same way that you would with a dynamic array in Excel. And the +1 is broadcast over each element of the array that it's being added to. That's a bit of a mouthful, but it produces the result that we want, which is, oh, I didn't uncomment them. That's not very helpful. Let's try again. So we now have 14112 instead of 03001. To add them together to get the results, the numbers that we want to concatenate, is a simple affair. It's simply just adding them together. So it performs element-wise addition in the way that you would expect, and that will give us 6, 10, 4, 6, 8, which are the numbers that then need to be concatenated to produce the result. In order to concatenate them, that array of numbers must be converted into an array of strings. We can do that using np.char.mod, where we interpolate each element of the second argument into the string format in the first argument. If you want to know more about that, I suggest you read the documentation. It's clear as mud. So we now have an array of string representations of numbers, which can then finally be joined using empty string.join, the same way that we did in the previous solution. That will then produce the required result. So seems complex, but it's actually much faster to execute. I like this because there's no iteration, there's no list comprehension, there's no for loop, there's nothing like that. So let's do a speed comparison between both of these solutions and see which one's better. I've got them here. So I've added this %% time it command to the beginning of the cell. This is the first solution. When that runs, you will see a message come up here. And it will be pushed down the screen, and when it's finished, I will show you what it actually looks like. So that first one, on average, takes 2.21 milliseconds to execute. That's super fast. No one really cares the difference between that and anything else. That's fast enough. But let's do it to the other solution. Execute that, and it's executing everything again, so forgive the delay. Okay, so 2.72 milliseconds for the first solution this time, but look at the timing for the second solution. It's 474 nanoseconds, or microseconds, I should say. So it's significantly faster, the second solution, and that is because NumPy is much, much faster. And we're not using any list comprehensions, we're not using any for loops, we're not using iteration at all. We're using a 3-dimensional array, and that's why it's worth learning, because it's much faster. Thanks for watching. Have a great day.